New day. 4 more problems. I was checking my email a little bit ago, and I got moved to team matching with Google. So I made it through. I think I made it through the final interview. Got put into team matching. Need to fill out some paperwork, and I guess see if I can get matched with the team. I think with Google's process though, it makes it a bit more difficult because passing that interview doesn't actually guarantee you get anything. But yeah, it's pretty neat. It's not an offer yet, not an offer just yet. But I mean, I guess then, why does it have to make the decision so much more difficult about what to do and what to take now? Yeah, but I guess we'll see. All right, let's go ahead and get started on this one. And maybe I can start, like, actually stop practicing at the end of this week. Have you started your Microsoft job? Not yet. I think I'm scheduled to potentially start. I think their start dates are like Mondays, but it's like, I think minimum 8 weeks from graduation, but at most 3 months. Oh wait, no, it's gotta be at least 3 months from graduation. That's what it was. Because I graduated in March, so I just gotta figure that one out. Alright. Given a lowercase string s, eliminate consecutive duplicate characters from the string and return it. That is, if a list contains repeated characters, they should be replaced with a single copy of that character. Hey, the string, welcome. How about in? The order of the elements should not be changed. Okay. I guess the other question is, can we have, yeah, okay, so can... This one is going to be just an n traversal. Oh, n traversal. Keep track of current character. If it is not the same as the cur, add to builder, then replace remote. I think with Microsoft, they're all remote at the moment. Microsoft they've tried to go back into Office, but from my understanding, they've pretty much indefinitely, as of now, postponed it. Okay. And update current car. Okay. I think that really should just be kind of the solution to this. Alright, let's go ahead and implement it. So we're going to keep track of the current character. Car C equals S dot. For now, I guess we can just do car equals S dot caret 0 car at 0. Then we're gonna do a string builder. The S equals new string builder. And what I want to do is add this first character to it. The S dot add. We're gonna add this first character. By doing so, we have our starting point because we know it's not going to be repeated, and then we can iterate from the second element and forward. There we go. Very confused. Oh, I didn't indent anything, that's why. That's why nothing is aligning. Okay. So if s dot caret I is not equal to current, we're gonna add it to the string builder. I could never get it before. Is it not just and this variation isn't even the usual compressed string, then we the s dot char at, not the s dot, just s dot char at. Cur equals s dot char at I. And I think we should be able to return here the s dot 2 string. Does not compile. Is it append? It might be append. Really difficult to remember all these very specific names. Alright, perfect. Okay. Strictly increasing linked list. Given the head of a singly linked list, return whether the values of the nodes are strictly in an increasing order. Alright, so what we're going to do is, first of all, going to iterate through. We don't care about returning the list. We don't care about keeping track of a pointer to the head or anything because we don't need to make any modifications. So what we're going to do is say while head.next is not equal to null, because we need to check the node after it. First of all, if head.next is equal to null, a list of one element should still be strictly increasing. Then, what we can do is say if strictly increasing is not, so having two elements of the same value one after another are not. Let's see. Head.next is not equal null. If, okay, wait, yeah, so we're checking head.val is less than or equal, is greater than or equal to head.next.val. We're going to return false. And then down here, once we get to the very, very end, we also need to move the head along. We're going to return true, because if we've made it the entire way without breaking out, we should be good. Very nice. Okay. What can we go from here? No new friends. Okay. So you were given n people, represented as an integer from 0 to n, minus 1, and a list of friends, tuples where person, friends at I is 0, and I are 1 at friends. Return whether everyone has at least one friend. Huh? So I'm trying to figure out, this seems overly easy, potentially. I don't even know what to do, man. Like, this Google email's thrown me off completely. Okay. Oh, aren't we just checking to see if every... Because we're given the fact that this goes... So, let's see. We can do something along these lines. Java strings remove Sophia penetrating to use memory. Huh. Okay. Let's do this. We know we have n items, right? What we can do is the graph is bidirectional. Make a set, add every one we see into the set. If set size less than n, return false. Is that not just the question? Because I mean, all we care about is it seems very, very easy for one of these. Let's go ahead and implement this real quick. So we're going to make a set of integer We don't even need to treat this like a graph problem, I don't think. So if we're going to do say for int I equals 0, I is less than friends.length. Let's do that. Perfect. Okay. So we're going to add those numbers to the set. And then just here return set.size is equal to n. Just not compile. Why not? Because I've been programming in JS for so long now that I keep forgetting things are methods and not like. Okay, last one, I guess. Binary search tree iterator given. Implement a binary search tree iterator the following. Next returns the smallest element in the tree. Has next returns whether there is a next element in the iterator. Ooh, this one is gonna be interesting. trying to figure out how to even approach this one. for it, honestly. Ooh, does not compile. It's not list its values. Keep messing up these names. Ooh, that's wrong answer. Let's do this, right? Print out the values here. No dot val. This should allow us to really see if our traversal zero, 1, 2, 3. How are we getting 0, 1, 2, and 3? I'm so confused. What? How can we... Why isn't the example here? What? 2, 1, 3, 0. Where are we differing from their solution then? Very confused about where we're differing. True, true, 0, true, true, true. There we go. Nice. Yeah, it was just the fact that we were skipping that last element. Because when our index is equal to the last element, we still have a last element to work with. Not the terribly fastest solution, but let's see. Because this becomes an issue when we need to add anything to the tree or anything like that. But if we're just doing an iterator, this should be fine. Can we store the information in another data structure? Else too, can we parse the tree into another data structure? Might help out. Okay. How do I finish editing? There you go. I'm curious about other people's solutions and to see if anybody... So, okay, this person needs a stack to fill it. Interesting, okay. What else do we have? A DFS. So everybody used... Here, why did they use a stack is my question, though. I don't even know what to do anymore. I still thinking about the Google email. That's the only thing that I can... Oh, wait a minute. I actually got like a problem that I hadn't done before. That's cool. Still 198 for the easies. Man, maybe one day I should just finish out all the easies. But they're so, like, just tedious. Tedious to do, tedious for edge cases, tedious in pretty much every sense of the word here. I'm gonna take a little bit of a break and then I'll be back to, I think I want to try maybe speeding up one or two of these. I don't know which one, but I'll figure something out. Okay. What now? Finish the session with 20 minutes left. I guess we can hop onto LeetCode and see if there's anything interesting to do there. Let me pull this tab aside. Don't want to go revealing personal information just yet. Okay. There's a very interesting extension that I have installed. It's called, what's it called? React Developer Tools. If you ever worked with React, it's quite handy to have. It just helps you see sort of what version of React a page is developed with, potentially like do more analysis on like a React-based web page than you could do, and it lights up every time a page is built with React, and it's lit up so often I forgot it could ever be a different color. There's one thing that I did find funny though. I think it was like Fred Meyer or they're like Fred Meyer Jewelers website. It's intended to be like a professional corporate website, but whoever built it for them just neglected to change. They neglected to change the default like icon that goes at the top of the tab. So it's just, let me see if I can find a way to really to bring this in here. It's strictly just like a React default template on this like professional corporate website. I don't know why, but to me it was just like the funniest thing that they paid somebody probably multiple thousands of dollars to do this, but they just yeah, hold on, there we go. They just did not remove the React icon. It's just there, and nobody's done anything about it, and I doubt that they ever will. But like, man, come on, if you have a proper corporate website, at least have your like icon there. Let's get rid of that. Okay. Gonna go to problems, and let's see what we can do for now. What's the most sort of like frequent problem here we can see? Why is add digits? Okay, two sum. Let's solve two sum. Give a little bit of an overview on. I hate the fact that LRU cache is up here, man. Screw this problem, man. Screw LRU cache. Let's do two sum as a bit of a send off. I mean, I do want to continue to do it until I at least get like either fully rejected or I get team matched by Google. But that's going to be something for me to figure out after this. I've heard that some people, their dates are set out like all the way in March, having passed like the final interview in January, so I guess we'll see. Guess we'll see how that goes. Okay, let's unplug this laptop so I don't kill the battery. And let's solve two sum. So what we need to do is keep track of the numbers we have seen. Look for complement in the array. So return indices of two numbers such that they add up to... Ooh, this one's indices though. This makes it a bit more challenging. This is more difficult to sum. You may assume that each input would have exactly one solution. Interesting. So how can we do this without traversing the entire array that was previously there? Because we can't store it by their indices, because that sort of defeats the purpose. We can't store it by the value, rather, because we need to know what index it is, and there may be two of the same value. Oh man, I actually don't really know how to approach this. I'm kind of curious, what was the solution before I removed it? So, it's the map, yeah. So they're storing, what are they storing here? So, iterate through the array. Can't you just do a nested loop in an if condition? Yeah, you definitely could, but that's n squared with one space. There is always a O of n time O of n space solution to these. So that's what I was trying to go for here. Okay. If map.contains key target minus nums. So if the map does not contain the key, which is the complement, we put the number and the index. Okay, so it is the way that I was thinking of it, but I just didn't know how it would work with this. But granted, you would end up, if there's duplicate numbers, it doesn't matter which one of them you grab, as long as you grab one of them. And considering there's only guaranteed to only be one solution, that avoids that condition. So yeah, I was thinking kind of down the right path here. Result map.get target nubs at I. Yep, and you return those two values. Sweet, okay. I guess for the time being, we have these 15 minutes. I do want to go over my solutions to these and sort of go over time and space complexity. Okay. So for this one, I looked at the problem and realized that what we're trying to do is remove duplicates, and my initial thought went to a set, because sets allow us to keep just sort of singular singular copies of things and they don't hold duplicates. However, after reading kind of further, I realized that we do need to keep the order. So for example, we have A, B, C, A, D, and F. So we need to keep that order in the end. So the next thing that I thought about was doing a sort of two-pointer-ish approach with one pointer, where we iterate all the way through, and what we want is to look for every single time a character changes, because when a character changes, it means we're done with the repeated portion and we can go on to the next one. So what I did was I kept track of the current character, and iterating through our entire string, anytime I found a character that did not match what our current character was, means the character's changed. And by doing so, I would add that character to our new string and update the current character to the current one so that for the rest of the duplicates, we just don't look at them. So we'd go through, find A right here, then we'd go through, we see A, we find B. B is different than current, which is currently A. So we add B to the string, we update curs to be equal to B, and we just continue going. And that allows us to get this right here. The time here is O of n, and I believe space would be O of 1 if I'm not mistaken, because we're expecting a string return. So, moving on to the next one, strictly increasing linked list. This one is, I think, probably one of the easiest linked list problems I've seen. It allows you to really sort of get the ropes on what a linked list is and how to work with it. So what I did was pretty much say, hey, if it's only one element, then it is strictly increasing by, I guess, just my definition of a strictly increasing list. It doesn't give a example of a list that only has one item, but let's see. Into a different also note is every solution I saw. So after looking, I guess the other way that you could do it if you really wanted to that way is keep track of where you are with like an index and just do a traversal until you hit that index. So yeah, then we iterate through the list, checking current and next. If the current is ever less than or equal to, we know it is not strictly increasing. And otherwise, keep moving. And otherwise, once we've made it to the end, let's see, made it to end. We know that it is strictly increasing. This is done in, I think this would be still O of 1, O of n space with O of 1 time. And there we go. Very, very slow this time for some reason. Great, let's move on to the next one here. So, no new friends. This one was very interesting because looking at it as a graph problem, you can try and do this whole thing where like you do like a BFS from one of them, you build out an adjacency list or an adjacency matrix from these, and it becomes this whole sort of ordeal of things. But one interesting property that I noted was that we are given a list, not of connections, but we are given a, I guess we are sort of in a way given a list of connections. However, one, a node cannot be its own friend, and two, If a node does not have a connection, it will not appear in the list of friends or the list of connections. What this means is that we can check to see how many distinct nodes will appear in that list, and after checking, we can check to see if how many of them appeared. And because we're guaranteed n people, we know that if our set is not n people long or n people big, then we know that there's at least someone who does not have a friend. So this is done in, I believe this worst case scenario, this is a n time n space. And going on to this last one really did stump me for a while because I was not really sure how to tackle it. I kept trying to visualize in my head how we can keep sort of an index in a BST, and then maybe we could remove an item from the BST, but then you remove the root node and you have to do all these rotations, and that just makes it stupidly complicated. I don't know if there is a faster way to do it, because mine works in O of n time and space. There has to be a way to do it in just n time. Because my best guess for modifying this one to be n time would be to count nodes in BST, and then keep index, do traverse to that depth, call it good, and return that one. I think I could potentially try and implement it that way. So let's do this, right? Int length equals 0. Actually, no, that makes keeping track of the index super difficult. Because let's say we had another one down here. Index 0 would not be just traversing down by 1. It'd be... Ooh, that's hard. Yeah, I'm not sure how to do that. But yeah, for mine, I pretty much traverse the whole tree by using an in-order traversal. In order is left, center, then right. This is because we know that the smallest element is always in a BST, not just a binary tree, a binary search tree, is always on the left. Then the next biggest one would always be to the right of it, and then the biggest one would be to the right of that, which would be the rightmost node. So I traverse those, I put them into a list using an in-order traversal, and then I just keep an index and iterate through that list, and that really is all there is to it. Alright. Goodness, this is getting very complicated. I'm not sure what's going on here. Can you do it without keeping the list version of the tree? That's what I'm trying to think of a way to do. Because I think the way to really do that would be to, again, find the length of the tree for the has next. Then, what we can do is, there's got to be some sort of like arithmetic operation we can do to figure out where we are in the tree. Because, for example, here, we can go as left as possible. So we want this one, then this one, and that one. You would need to, I think, maybe like keep it as a balanced BST, maybe. So you find the 2, you remove the 2 from the tree, and then you rotate the tree around the 7, so you get 4, 7, 5, 9. Then you go to the left again, you remove the 4. Then you rotate it again, you get 5, 7, 9, you remove the 5, maybe that might be it, honestly. You might have to just like remove leftmost, do appropriate rotation. And then just kind of keep doing this until, if you have a node, you you have, what's it called? A next. I think that would probably be a way to do it. I guess let's look at the solutions here and see if anybody has done it without. So stack. Yep, so that's a queue. Oh, that's cool. That's a very interesting way to do it. So you don't necessarily traverse it right off the bat. You traverse it as you go. So you add the root to the queue to get to the very, very left. And then you just keep adding things to the queue, which ideally gives you the smallest one. Interesting. Okay, what about like an in place? So this is using a list, DFS recursion with a list. It's using a stack. Compute the values of the constructor before forming a traversal of the tree. The latter nodes which utilize the list and the pointer to keep track of current positions. I think keeping the right children you didn't follow yet for following them later. Yeah, I can't seem to find any examples of this being done. Without using any sort of other data structure. Let me look it up. Hold on. BST iterator in place. I think there's an in-place version, but it's madness for an interview, even for an on-site interview. That's what it seems like, because I don't want C++, give me Java. So yeah, for this is on Geeks for Geeks of a stack is empty. See, but this also utilizes a stack. I think to do it in kind of a O of 1 space, you would need to do a whole thing with like because you can't even do a level order traversal because that does not give you the correct one. So it would probably have to be something absurd with like rotations and things. When you were at the root, you attach the right child to the last node on the left subtree. So you go all the way down, and then you attach this node, let's say, to the 7 down here, is what you're saying? Yeah, that's very confusing. Oh, this is one of the most frequent Facebook tagged questions. So you're telling me that there is a better way to sort of do this in place, huh? Let me check out LeetCode, see if I can find it. If I can find it, I'm sure I can find like an in-place solution there. Yeah, that doesn't work in order. So it was one of the most tagged binary search tree iterator. I found it. Okay, let's take a look at this and see what we got. Submissions, there was an accepted one. I imagine this accepted one from whoever did it previously. Most likely utilizes, yep, that's the list one, not the in-place one. I think it is way better to keep the path you've taken, so it's log n space. Would it be log n space? I think it'd just be O of n, honestly, for every node in the list. Okay, there is a solution by LeetCode. Okay, let's see what they've got. What are you trying to do? Just got here. Looking at this binary search tree iterator, trying to see if there's a way to solve it without utilizing extra memory. For example, without utilizing a list, or I've seen lists, stacks, and queues utilized for this question, but I'm trying to see if there's a way to do it in place with utilizing just what a binary search tree gives you. Okay, let's see what we can. So this is using an array list, um, controlled recursion. So this is utilizing a stack. Yeah, man, even LeetCode doesn't have an in-place solution. But I do think utilizing a stack is better for space complexity than using a list. It is less space consumption. Because like somebody pointed out down here, can't do that to get to the max. My best thought for doing it in place was to, for example, traverse all the way left, remove it, and then do a rotation around its parent. So for example, you do 2, you remove 2, you do a rotation around the parent, and I think that it's been a while since I've done like binary tree rotations, but I think by doing that every time. Alright, at node n you need to attach n to the last rightmost node of the left subtree. I wish they gave another like example here, one that was more sort of complex. Overall though, very interesting. Heal that didn't even consider. Overall, yeah, very interesting set of questions. I think hopefully it was interesting. This question is gonna keep kind of popping up in my mind for a while now because just draw a larger tree. Okay, let me pull up Paint real quick. I think I have Paint set up as one of my inputs here. Where's it at? Do I really not have MS Paint anymore? I thought I did. I guess I don't have Paint. I guess I can't actually... Okay, next time. Next time. Alright, I think that's gonna be it for me today. Gotta run, prep for a midterm I got in a few hours. Get that over with and then get back to working. I guess the one thing I can kind of share, it's, let me pause my stream music here. So we're working on a, oh sweet, okay, hold on. I will definitely take a look at that. Let's see what we got. February 16th, 2020. That's 2 years ago. You know, I'll definitely take a look at this. I've heard about Morris traversals, but I haven't actually gotten to do anything with them. Haven't gotten to look into them. But yeah, we have a project we're working on for one of our courses. It's a 10-week-long project, and we are pretty much building a game from scratch using a very, very simple JS game engine that pretty much has like a draw loop, an update loop, and a what's it called loop? Draw, update, and... No, that's it. That's just the draw, and update loop. But let's see if I can get this to play. Oh wow, where did our like main game music go? How did I lose that? But yeah, we have worked on implementing sounds recently to where I hope it goes through. Oh, that's really loud on the headphones, isn't it? Let me tone that down a little bit. But yeah, now you have somewhat functioning sound effects. And I never realized just how much sound effects will really change how you see things, because they make it feel like a significantly more complete game. I'm trying to figure out why the background song just does not want to play here. Did I mute it somehow? Weird, it was working yesterday, cool. I love it when things just stop working. But yeah, it allows us to have a significantly more complete feeling game. There are some issues here and there, but I think I mix and matched the sound effects from separate characters in this game. But it's pretty cool. There's something I do want to get to here in the end. If I can actually make it there. Get out of here. I spent way more hours than I think I'd like to admit working on a mini-boss for this. Well, there's also no spike collision. This is very loud for me in my ears, so I hope it's not... I think I brought it down enough to where it's not like obnoxiously loud over stream. There's also a lot of collision glitches still, working on fixing that, but a little proud moment seeing it actually come together. If I could ever... You know what? Screw it. Spikes it is. Yeah, this dude. He is very, very big and very intimidating, and it's very difficult to not... What's it called? To not make him more difficult than he needs to be, because it's just changing a single number that makes him more difficult. And it's a lot less cool without background music, you know? Don't know why it's refusing to play it, but I want him to do the cool attack that I had to, like, tone down because it was too cool. Okay, not that one. Come on, buddy. You can do it. I believe in you. He's under a lot of pressure from the 3 people watching. Just do it. Come on. There he is. This one's very counterintuitive to dodge because if you run away from it, I think you pretty much get caught in this place where you just cannot avoid it. His death animation also just is non-existent. So he just kind of disappears. Get way further into writing the game than I ever have. Good job. Yeah, no, it's been a challenge, definitely. To put into perspective, our player, like, JS file is currently